Hi, Waylon.
Hi, Waylon, yo. Because that. So I'm gonna actually post this one so that Waylon and Carolyn and Mackenzie feel a part of our team. Yeah, because Mr. J's like better than me, so I like to use his videos. Yeah. Sure, we're gonna do this. Check your voice, track the board. If the aim is written, give me a thumb up. Go to, you're good. Okay, we're all caught up. So 3n times n squared minus 64 is our first example. Notice that we're using a word called polynomials today. We've been working with monomials. What is a polynomial? Think about it for 10 seconds. It's in your first lesson of the year, 1-2. What is a polynomial? It's not just a monomial. It's a little different. Wyatt?
Expression with multiple factors, and it has to have one or more. No,
yeah, I'm gonna change that vocab to term. It can have one or more. So this could be a polynomial. This is called a binomial. You could also have a monomial, which is just 2x. You could also have a trinomial, which is 4x squared plus 2x minus 2. This is binomial. This is monomial. And this is tri. All of these things are polynomials. They all fit under the category of a polynomial. It's kind of like, thinking of a science example. It's really lame. If you look at different trees, my dad used to be a forestry person, and so every time we went on a hike, he would look at all these different trees and categorize them, but they're all trees. But he would be really specific and that's a coniferous pine tree. It'd be really embarrassing. Yeah, I don't know what the trees are. I didn't pay attention. I was just trying to hike. What? Pies. I'm sorry, we're not at 100. Okay, keep going.
No matter what, you can say it's a polynomial, even if they're looking for a monomial, trinomial thing.
It's not gonna ever have that vocab. That's more of just for your back pocket, so you know that that's a term if it pops up on the SAT in high school. Where I'm not gonna quiz you on the vocab. We don't do vocab quizzes. Because you're gonna take Algebra 2, and that's gonna be a refresher for you. You'll take Algebra 2 before the SAT. So this means multiplying. If a number is outside parentheses, you're going to multiply 3n by everything inside of the parentheses. Just like the regular distributive property, if it looked like this, you would multiply 5 by everything. You don't need to write that. That's an example. So let's start with 3n times n squared. What would that become? Well, they're like terms, and I'm thinking my operations of exponents. What type of operation am I doing? Tony. Multiplication property, that's the product property, yeah. So I'm going to add 1 and 2 because I'm multiplying two n's together. 1 plus 2 is 3. 3n becomes 3n to the third. Question? Yeah, Tony? Question? Tony? Okay. Next, we're going to do 3n times negative 64. Yeah?
I was just, it's bothering me. They put this answer under the equal sign and not next to it.
3n times negative 64. Well, there's no n for this term, but there is a number. That's a coefficient. 3 times negative 64 is my operation. So let's go ahead and do that to the side. 64 times 3. And then include your negative. Answer, hand up. Scratch work. I got 1, 2, 3, 4, 5. Felix, answer.
192.
And it's negative, right?
Yeah.
Okay. So this is negative 192. But there's something next to the 3. What is it, Felix? It's an n. So this entire thing, that 2 looks weird, is negative 192n. Did I have to change the n to an n squared, Tanner?
What?
Did this have to change to an n squared?
I don't think so.
No, because it's just an n and there's no other variable to multiply it. So let's combine these two things together. And we get 3n to the third minus 192n. That's our answer. Which one is that? C?
Yeah.
Okay. Could I have written question?
I have a copy of
Could I have written this answer like this? Are those the same? Turn talk, yes or no, go.
I mean, yeah, but it's just not right.
Why isn't it right?
Yeah.
Because mathematicians like the thing in
I don't like it. All right, back to me. So could I have written this, Jordan?
And technically, yes, but I could overhear you saying stinky, saying like you didn't like it the bottom way. So even though it technically works, because we don't want to get a bad grade.
So the thing you're thinking about when you're working with exponents is the higher the exponent, you're working it on the left. So if you have an n to the third, that should go before the n next to 192. Always put the higher exponent to the left. That's the most accurate way of writing it. Example 2. You have a monomial multiplied by what type of polynomial in the parentheses? I'll take a hint. This is a monomial for 5k. What is inside the parentheses? Kylie. It's a trinomial. So nothing really changes except for I'm multiplying 3 different times instead of 2. 5k times k squared becomes what, Porter?
5k to the third.
Good. 5k times 6k becomes what, Lexi? 5k times 6k becomes what? 30 what? K times k is product property, tells me to add exponents. 1 plus 1 is? Okay. That's 30k to the second, and then 5k times negative 5k? It's not. It times negative 5, you're correct. Kingston, what's my answer?
5k times, right? 5k to the third, 5k to the second, minus 5k.
Good. So put that all together like Kingston did. You're going to list 5k to the third first, plus 30k squared. Where's my blunder? This is intentional, don't mark it. What's my blunder? A really common blunder when we were working with polynomials. Where's my blunder? Got 2 hands. 3, 4, 5. Jackson. Yeah, when you have a negative right here, that minus sign's got to come up to be a negative 25k. What, Tanner? Question?
I was just no,
Okay.
it's just bad.
Example 3 is where we start getting into something kind of fishy. What's the area of the rectangle below? Was that a what's it called? A burn, a diss.
Yeah, I was
Okay,
gonna say,
I'll
why
take
do your
it.
K's and
That's fine.
V's?
So this is because that's how I write K's.
It's a V with
This is a weird problem. Here's why. I have first this box, it's a rectangle, and it says find the area. I find the area by always doing length times width. and it'd be this side times that side. So that's the area. First, it just looks kind of weird, Elliot, but that's what we're actually doing. So I'm going to multiply 4x minus 1 times 2x plus 5. I'm going to get, don't write this, 8x minus 5. That is wrong. Why is that incorrect? 5 seconds, then you're chatting. 4, 3, 2, 1. Jackson, you can turn around and talk to Sarah. Kieran, you're joining that group. Turn and talk to your partner. Turn. Why is that wrong? Ooh, I'll do this. That's also wrong.
You didn't. Why is it -5?
-1 times 5 is -5.
It's multiplication.
5, 4, 3, 2, 1. I'll take a hand. Why is this incorrect? I saw someone caught a blender that was 4x times 2x, which would be 8x squared. I got that up, but that's still wrong. What is messed up with this? No, I caught it. Wyatt. It is not 6x because this is a multiplication problem. Addison. -1 times +5 would still be negative because I'm working with multiplication. Elliot.
Why did you multiply the 4x to the 5?
That is what we're going to get into. Okay. Anyone else have a comment? Sasha? Tanner, check your voice. I'm going to pause you. This is too important to get into that. Sorry. 4x times 2x. Voice off. 3, 2, 1. Tanner talking. Jordan talking too. Okay. When you have a binomial times a binomial, things get kind of weird. And it's not just multiplying the x's and the constants together. You have to do something that's, I like to say, going to the party. And so these guys, 4x and -1, they're a couple. They're a pretty nice couple. They've been maybe dating since like 8th grade, and they're now in senior year of high school, kind of like Mr. Mackey's relationship. And they know each other. And you guys will hear part of my love story in about a month when we get into another lesson. But these guys, 4x and -1, meet 2x plus 5 at the party. And they're really polite. And so 4x always goes to shake the person that he meets first. So 4x shakes hands with 2x. That means multiply. 4x times 2x is 8x squared. That's to the first. Okay, so that works. But then 4x sees 5, and 4x is really polite. So 4x also shakes hands with 5. That's 20x. Okay, and then -1 is also polite and very respectful. She is going to go and shake hands with the 2x next. -1 times 2x is -2x. There's one last person that she has to shake hands with. That's a 5. -1 times 5 is -5. This is almost the answer, but it needs one last step. What is it? Jordan, do you have the answer?
You have to subtract.
Keep going, yeah.
You have to subtract 2x and 20x.
These are like terms, so they can combine, and it's 8x squared minus 18x minus 5. This is your trinomial answer. You're going to get extremely comfortable with this. This is the base of Algebra 1 answer, yeah? I did make a blender, okay. Colby, what is my blender, Colby?
You did -18.
Yeah, thanks. That is a good example of a common blender. If you want to, I'll show you an alternate way of setting this up that looks like that, but you can keep it like this for now. Example 4. In summary, before we move on, when you're multiplying monomials, polynomials, every single term, do you have this in your pocket? Needs to be distributed to every other term. You have to shake hands with everybody. Did I have to multiply the 4x by the -1? No, I didn't have to do that because we were a couple. We already knew each other. It'd be kind of silly if I greeted my wife every morning with a handshake and said, "Good morning, I'm Mr. McAtee." That'd be even weird because then I would say Mr. McAtee. Yeah. What? Okay, y minus 2 times y minus 8. Rewrite this over here so we have room to work. Board the paper, Wyatt. Rewrite it so I have room to work. Y is going to go to the party and shake hands with Y. Y is going to the party and shaking hands with 8. For today, I need to see this operation on the side. Here's your scratch work. You need to write this. Y to the first times y to the first is y to the second. Today, I need to see this work. Y times 8 is 8y. Then we move to -2. -2 goes to the party and shakes hands with y. If you want to stack your like terms together like this is a strategy that some people find useful because it avoids a blunder that I made in example 3. I can kind of see what's happening clearer. It's 8 minus 2y. This is an option that you can do. If you don't like it, you can just list it out horizontally. Last handshake, -2 times 8 is -16. Question? Yeah.
So I could be wrong, but they're saying they're in a relationship, but by meeting up and new numbers are great.
There's a whole range of jokes you can go with this. There's like, yeah, they're doing something weird at the party, and then they're like creating a whole nother group of people. It's like some alien sci-fi thing happening. There's also another route you could go. In 8th grade, I'm gonna pause you and just divert that attention, and we're just gonna do math now. Yes. What?
I am so confused what just happened.
Okay. M plus 4 times m plus 5. 2 more. Yes. For today. Starting tomorrow, you don't. It's a lot more work, and there's a reason I make you do it for today. Because if you start to get the hang of it, Elliot, like you guys are extremely just intelligent in general, and you start to like get too comfy in the bronze problems, then you start like going too fast. And so I'm forcing you to slow down today. This should be mental in about like 2 weeks. You should look at that and automatically get the trinomial. But I don't want you to do that yet. M times m and m times 5. Get ready to cold call Vienna. What's m times m going to be? M to the second power, good. And m times 5 is what, Elliot? M times 5 is? Good. Lexi, what is 4 times m? Good. Where does that go? Do you want to put that to the right or underneath? Sure, both are correct. If you like that method, go ahead and roll with it. If not, do it horizontal. I'm okay with notes looking a little different for that step. 4 times 5 is what, whole class?
20.
Okay. Combine like terms for the answer. Maya. Because those are like terms, 5m and 4m can combine. That's why I wrote them underneath it. And if it helps you to combine like terms by writing anything that's common underneath the common one, do that. Okay? Ooh, we got 2 more examples. All right. X plus 3 squared. When you see a little sign up here that says to the second power, that's the same thing as writing it twice. So it's multiplying by itself in parentheses. What do I do first, Abby? Okay, and what's the answer? Okay. Next step, Wyatt. 3 times 3? Not quite. I'm going to do something else. So I did 3 times, I did x times 3. Okay, and now we have 3 times what? 3 times x. Yeah. 3 times x again, you have to do it twice, and then 3 times 3. Okay. That's what's happening in this one. And give me the trinomial Lexi. Good. This one is going to be a common one that we see a lot in algebra. Yeah.
Wouldn't that also just be x squared plus 3 squared?
No. 3x plus 3x is not 3x times 3x. So you cannot...
What's the problem with a square with a 2 over it? That means you make an addition.
I see what you're doing.
You make each one squared. So you just do that?
No.
X squared plus 3 squared?
No.
Why not?
Because it's not x.
Because you multiply each one by square, so each of them would be square.
It's different because you have a binomial, and because you shake hands with everybody, you don't just do x times x and 3 times 3. Because you have to shake hands with everyone. You have to. It's the property of distributive property in math, and you can't just do x times x and 3 times 3. That was like the common blunder I showed, right? Yeah.
What if COVID's still a thing and I don't want to shake hands?
Example 7 is 4x plus 9. It says product, which means multiply. Underline that so you know it's a multiplication problem. This time I have a binomial times a trinomial. It's going to get pretty large, but we can still do this problem. 4 times 2x squared is first, then 4 times negative 5x, then 4 times 3. Elliot. Where? Thanks.
No.
Anybody but look out. Yeah.
Okay, 4x squared times 2x squared is...
Goofy on.
Boys, 3, 2, 1. 8x to the third is the first one, right up below. 4x times negative 5x. On notes and homework and independent work, Elliot, I'm expecting to see these lines being drawn. So you're telling yourself what is happening. Negative 20x. And then 4x times 3, which is 12x. What do I do next, Porter? 4x shook hands with these 3 guys, which is a funky relationship. Yeah, 9 times what?
2x
Sure. What is that, Porter?
squared is 18x.
Okay. I did something wrong. No one caught it? Woo! That's squared.
Blunder.
Nope.
Yep.
No, I caught it. I was just
Nope.
testing.
Sorry.
No.
9 times 2x squared equals 18x squared. Okay. Where do you want to put that, Porter?
With negative 20.
I would probably put it right underneath and make it positive. 9 times negative 5x is negative 45x. And 9 times 3 is 27. I'll let you do that mentally. Simplify this, Sasha. What do you simplify first? What do you want to simplify first out of these 2? Simplify this to get the answer. Good.
Negative 123x.
One more.
30.
Good. Do I subtract the x by the x and get 33? No. It's just like an exponent that stays with it. It's going to be an x any way you subtract. Bring down the 8x to the third, bring down the 27. That giant thing for now is your answer. This is a quadnomial, I think. Yeah?
One day we have to solve that like completely.
Yes. You will have to solve that. Question. Yeah. Huh? Sorry. Do you want me to go up? Why, stop. What's on your shoulder?
What's down in your Oh, my knee hurts. Actually, yeah. My knee hurts. I can't sit on your foot. No.
5, 10. We're going 50-50. You have 7 minutes to do partner work, 7 minutes of independence. Pencil up if you're ready. 3, 2, waiting on